Welcome back to the Explainer. Okay, let's dive into something that is literally mind-bending. I want you to imagine, just for a second, that the Earth, which right now is spinning at over 1,000 miles per hour at the equator, suddenly halts. It completely stops dead in its tracks for exactly 1 single second. I know, it sounds like the setup for a ridiculous Hollywood blockbuster, right? But today, we're going to break down the actual, terrifyingly fascinating reality of what that single second would look like.
So really ask yourself, what happens if Earth stops for 1 second? It's super easy to jump straight to movie tropes, Maybe the planet cracks in half or gravity just magically turns off. But we're actually going to pivot completely away from fiction here and look at a foundational, jaw-dropping truth about physics. Because honestly, the reality is way more interesting than the movies, and it all comes down to how motion actually works.
Listen to this quote from our source material, because it's absolutely crucial. A sudden stop does not erase motion. It separates the ground from everything that was already moving with it. Keep this in your head. This is your anchor for this whole explainer. Motion has inertia. Things resist sudden changes. Our planet isn't just a static stage we're standing on. It's a moving floor. And when that floor abruptly stops, the things resting on it, they don't just politely agree to stop too.
To really get this, we're taking a first principles approach. Here's our roadmap. Section 1, the 1 second reality. Section 2, the rule of sticky motion. 3, Earth's connected layers. 4, the deadly mismatch. And finally, 5, a breakdown in coordination. Let's get right into it.
Section 1. The 1 second reality.
Okay, we first have to totally shift our perspective on what it means to be standing still. Imagine the Earth as a spinning stone balanced in your hand while you're running next to an open field. If you suddenly stop that stone from spinning, the dust, the water droplets, basically everything resting loosely on its surface is going to keep trying to move exactly the way it was moving just a millisecond ago. You see, Earth isn't just sitting there in space. It's actively giving every single object on its surface a hidden, built-in sideways speed.
Which brings us to Section 2, the rule of sticky motion.
Let's look at the basic physics of why motion doesn't just, vanish into thin air. We call this sticky motion. It's the irreducible truth that once something is moving, it strongly prefers to keep moving the exact same way unless a physical force forces it to change. Now, it's not sticky like actual glue holding things down. Actually, scratch that. It's more like a deep fundamental stubbornness. An object has this intense resistance to forgetting its previous movement.
The real trick here is comparing our everyday human-scale life to the massive planetary scale. If you're riding a bicycle, right, and the road ahead suddenly just disappears, your body doesn't instantly stop. No way. You keep flying forward because that forward motion already belongs to you. Well, Earth works exactly the same way. The planet's rotation isn't some magical off switch for the stuff on it. It's a moving floor carrying oceans, air, and entire cities. If that floor stops, everything riding on it just keeps going.
And that leads us to Section 3, Earth's connected layers.
It helps to realize that Earth behaves a lot less like a single solid bowling ball and much more like a loosely connected system. Think of the planet as a planetary stack. You've got the rock and soil of the land, the water in the oceans, the air in the atmosphere, and of course, people and buildings attached to the ground. Each piece of this massive stack has its own entirely unique response time to a sudden halt. The solid ground? It stops first, but those other layers, they're fluid or they're just barely tethered to the surface. So, what happens next is a catastrophic loss of synchronization. Imagine being in a super crowded room where everyone is walking smoothly in the exact same direction, and out of nowhere, an invisible glass wall drops down at the front. The people at the front slam into it first, and that impact violently ripples backward. Or think of a fast-moving train that suddenly slams on its brakes. The luggage on the racks and the air inside the cabin all violently lurch forward. The system totally loses its shared motion.
Now for Section 4, the deadly mismatch.
This brings us to the absolute climax of this whole scenario. I want you to burn this simple phrase into your mind. The damage comes from the mismatch. Seriously, if you take away anything from this explainer today, let it be this. The sheer destruction isn't caused because the Earth is being violently pushed or pulled by some crazy cosmic force. It's caused by the brutal, unforgiving friction between the layers that have stopped dead and the layers that are still moving at hundreds of miles per hour. Just consider the duality of this event. On one hand, the ground halts, triggering an instant global structural crisis. Buildings, roads, bridges, they're all suddenly asked to absorb an enormous, physically impossible difference in motion. The attachments just snap. Boom. On the other hand, the atmosphere doesn't politely stop to wait for the ground. Air has mass, right? It instantly becomes a violent, invisible river. Literally an atmospheric battering ram slamming into the halted landscape. We're talking about supersonic winds tearing across the surface.
And honestly, the water is even more terrifying. Let's look at the ocean's chain reaction. First, Earth stops rotating. Second, the ocean just keeps its previous momentum. Third, the water piles up against the land and itself. Fourth, massive waves form. And fifth, coastlines instantly become impact zones instead of boundaries. It's like holding a giant metal bowl filled to the very brim with water. If you're walking fast and you suddenly stop, what happens? The bowl stops, but the water violently sloshes forward, spilling everywhere. That is fluid inertia, but on a terrifying planetary scale.
Now, you might be thinking, come on, it's literally only 1 second. Surely that's way too brief to actually matter, right? Well, let's debunk that right now by looking at these variables. Quantity tells us the massive mass involved. Speed tells us how far things want to keep moving. Duration tells us how long it has to keep going. But mismatch, that tells us how violently the energy actually gets released. At planetary speeds, a 1-second pause means the ground and the atmosphere are suddenly miles out of sync. It's not about how long the stop lasts, it's about the sheer, unimaginable amount of kinetic energy that gets violently mismatched in that tiny split second.
Which brings us to our final part, Section 5, a breakdown in coordination.
If we zoom out for a second, the supersonic wind, the apocalyptic floods, the total structural collapses, they really aren't separate stories. They're just one single story being told through different materials. The true disaster here isn't just an earthquake or a mega hurricane. It is the fundamental collapse of coordination between interconnected parts that suddenly, violently, fail to stay coherent. I absolutely love this quote from our source. When motion is shared, stability is possible. When motion is suddenly broken, the system itself becomes the problem. This elevates us way beyond a fun hypothetical scenario and turns it into a really profound lesson on systems thinking. Our world is only stable because all these vastly different layers, the rock, the water, the air, have all basically agreed to share the exact same motion. If you break that agreement, even for 1 tiny second, the entire system tears itself apart.
Which leads us with one final kind of terrifying thought to chew on today. If the Earth stopped for exactly 1 second, causing all this catastrophic sloshing, tearing, and wildly mismatched momentum, what exactly happens at second number 2? What would a sudden restart do to a system that was just violently thrown entirely off balance? I mean, the pause broke the coordination, sure, but the chaotic, violent recovery of the system being forced back into motion, well, that might just be the most destructive part of the whole shebang. Thanks for exploring this mind-bending reality with me.